The slide is visible.
Yes, yes, it is visible.
So first of all, good morning to all of you. And first we discuss some outlines of the today lectures. So what is blockchain? And in this blockchain, we have which types of keyword that can be uses to identify these types of concept in the blockchain. So first we discuss decentralization.
Dr. Amrendra Singh, may I tell you that we have already discussed for 3 days now. So participants have already been aware of these things. Just to tell you that today we will be focused. If it would be great if you focus more on alternatives. Thank you.
Okay, thank you. So first, we have discussed the core component of the blockchain and cryptography of blockchain, and the types of blockchain and what classifications of the blockchain, and why we need the consensus algorithm, and the security attacks and use cases of the blockchain, and the growth of the blockchain technology. So what is blockchain? I have already have no because we the previous day, the third day, so we have discussed the first we have discussed some decentralization of technique. We have consensus. So the consensus topic is covered or not?
Consensus is briefly covered, and you can start with general consensus mechanism, proof of work, then alternatives to proof of work. Thank you so very much for your understanding.
Okay. So we first discuss some basic example of the Byzantine generals problem. So in this example of generalism, they are just like three steps. First is a elect and vote and decide. So in this general example, we have commander is just like act as a leader, and three node faulty node is called as a lieutenant node. So that means we have discussed the analysis of algorithm of Byzantine algorithm. Yeah, any types of algorithm we have analysis. Basically, three types of steps that can be followed: elect, vote, and decide. So there is the analysis of algorithm. Generally, we can define a consensus algorithm by three steps: elect, on, decide. So in this figure, we have just first we have elect the leader. So here we have the commander is called as a leader, and elect means all the node elect a single process term as a leader to make a decision. So the leader propose the next valid output value in the particular network. So then next, first we have decide the leader. Then we have second command, we have act as a voting. So the non-faulty process listen to the value. That non-faulty process, that means they are lieutenant is a non-faulty and commander is a leader. So the non-faulty process listen to the value being proposed by the leader and validate it and propose it as the next valid output value. So we have received the input value of V, and then we have decided the receiving input value that can be in the basis of the we have given the output. So in this figure as a commander, we have sent the V message to all the lieutenant, and then all the lieutenant we have received the V message to the through the commander, and lieutenant 1 received the V message, lieutenant 2 received the V message, and lieutenant 3 also we have received the V message, and lieutenant 1 sent the V message to the lieutenant 2, and here lieutenant 3 sent the X message to the lieutenant 2. So in the lieutenant 3 is a territory the point of the lieutenant 2, because we have lieutenant 2 received the V message to the commander and the leader, and lieutenant also lieutenant 1. But here lieutenant 3 sent the X message to the lieutenant 2. So in this basis of voting, we have lieutenant 2 who decided which node is a faulty.
Yes, Dr. Amrendra.
Yes.
Your voice is actually pretty low. Is it possible you adjust
Yes,
the
yes.
volume? Thank you so very much. Thank you, sir.
So in the point of lieutenant 2 is it is clear.
A little bit better, yeah, but let's see. Let's see. Can you continue?
Yes, yes.
Thank you.
In the point of lieutenant 2, is a lieutenant 3 is a territorial because lieutenant 2 received the V message of the commander and
Perhaps
lieutenant
it is a mic's problem because can you please adjust your mic and position? Thank you.
I'm audible clearly.
You are
So
audible. You're audible, but voice is low. That's what we were saying. And if you adjust the mic, that noise comes. That is what participants are telling also. No, voice, Devnathji, voice is okay, but only thing is that the volume is low. That's what, like, otherwise it's okay.
yes,
If he,
so,
yeah, he's adjusting, please wait for a while, participants.
So in the point of lieutenant 2 is lieutenant 3 is a territorial because we have lieutenant 2 receive the V message to the commander and V message to the lieutenant 1. So in the basis of voting, we have next output we have decided. So we at least 51% voting we have received in the positive. So that means lieutenant 2 is a work on the follow the instruction of the followed by the V and discard the message of the X. So at this point of we have decided which message is which message is right or which message is wrong in the basis of the voting. So next step we have also decided that first we have elect the leader, then second message is a vote, and third message is a decide. So the non-faulty process must come to the consensus on a single correct output value. So if the leader receive a threshold number of identical votes for an output value that satisfy certain criteria, then the process will decide on that value. So here lieutenant 2 receive the number of thresholds values of input that can be decide which action is right or wrong. So this then the process will decide the on the next value output. So otherwise the start steps all over again. Then we have this elect the leader, and then we have send the message to all the lieutenant node, and then after we have decided the issue. Here are the issues of the many hamper victory. So if journal will hesitate to attack the appointed time if the does not get the acknowledgement from the lieutenant, so the enemy could capture the commander messenger and the intercept the message, and then they may attack to the then we have attack of the leader, so cannot verify the authenticity of the message. So all our lieutenant may send the acknowledgement message, but there is no assurance of the commander message. So will not be caught by the enemies and message intercept which have replaces. So this is a basic general problem of the Byzantine general problem. So this is only basic concept of the consensus algorithm. So here we have already discussed the definition of the blockchain technology in the previous lecture.
So there are some questions in the chat box. Would you like to
Yes,
tell in the end, or you would like to take it
I will check
now? What is the need for L2 for verification? Some people are asking. So you can tell your policy that you'll take at the end, or you would like to keep watching the chat box. Dr. Amrit?
L2 is a verification. That means we have L2 receive the different types of message. Just like in the previous L1, we have sent the V message, and L3 sent the X message. So L2, we have received the two types of message, X and V. But we have a number of threshold value is V, is a receive. That means commander also sent the V message to the lieutenant 2, and lieutenant 1 we have sent to the lieutenant V message to the lieutenant 2. In the basis of voting and the threshold value, we decided which message is correct and which message is wrong. So this is a verification process of the lieutenant 2. because we have, if malicious vote, if the threshold value of malicious vote is received from lieutenant 2, that means we have performed the wrong action. So this is basic only receiving the voting process of the lieutenant 2. If we have received the more number of wrong messages, we have performed the wrong message and wrong actions. We have received the right message to the in the thresholds value, we have performed the right action in the message. So this is equal to verification of the basis of the voting process. So this is getting directly from commander. Yes, commander, we have sent the all the message directly to the lieutenant, and then we have all our lieutenant. We also exchange the message to the lieutenant. Which types of message we have received to the commander and which types of message we have forwarded to the next peer nodes. Here, lieutenant is just like a peer nodes. They're all are connected to each other. If we have a lieutenant, if the network is at 10 nodes, we have all our 10 nodes we have received to the V message to the commander. And we have commander left, then we have rest of 9 nodes. We have sent to the inter exchange message to the all our 9 nodes. So we have those number of threshold value we have received. That means which message is a right and which message is a, just like we have a V message is at least 51% we have receiving vote of any nodes, that we have performed the which types of action. If less than 51%, then discard the message. So this type of voting process that can be only performed here in the blockchain technology, in the consensus algorithm.
Dr. Amrin Singh, sir.
Yeah. Yes,
Hello.
yes.
Yeah, so it seems that once it is getting message directly from the commander, so
Yes.
what is the need of getting it from some other lieutenant? Because it's against the general conception. In normal life, we never confirm. If I got a message from vice chancellor, I'm not going to get another message from professors or associate professors and then verify what vice chancellor has said.
So if we have decided that if coordinator is a faulty,
you mean if the commander is faulty?
if the commander is a faulty, the rest of node we have to check the message is provided right or wrong. So we have communicate to each other because all our node is connected to each other.
So commander is faulty means it is giving different message to the different lieutenants.
Yes, yes. The commander just V message sent to the lieutenant 1 and X message to the lieutenant 3 and Y message lieutenant 2. So we have all our we have checked to communicate to each other. We have received the different types of message. So we decide the commander is a faulty or not.
Okay, thank you.
Just like if two journal, so say journal 1 and journal B need to agree on the time of the attack. So the only way of communication is by sending the messenger through the city. So the simplistic way to send the message will be one general to take the leadership role. There are two generals, A and B. So one general is to take the leadership role and send a messenger through the enemy lines and attacker lines with the proposed day and the time. So the second general on receive the message and send back the acknowledgement on the agreement message back to the first general. So here there are the issue of many hampers of victory. We have also already discussed. General A will hesitate to attack at the appointed time. If he does not get the acknowledgement of from General B, so the enemy could capture the General A messenger and the intercept of the message. If there are two General A and B, General A is a leader. A sent the message to the leader, General B, and General B have received the message but not sent the acknowledgement. So we have General A is not authenticate. We have General B received the message or not. So we have not performed the action to the enemies because we have less number of lieutenant and less number of attack of teams. So General A message could be intercepted and replaced by the fake message. So General B may hesitate to attack as he cannot verify the authenticity of the message we have received from the General A. So if General B may send an acknowledgement message, but there is no assurance that the General B messenger so will not be caught by the enemies or message, we can be replaced or not. So one of the general could be potential by the terror. So this is concept which can be in the Byzantine general problem. So the lack of confidence or doubt between the generals may trickle down to the soldiers in the army, leading to some disasters and the composing of the strength of the army. So the dissertation can lead to defect even there's a coordinator attack. So hence there is no way for either the generals to guarantee the counterparts have received the message and between the two generals or two participants. So in a distributed network, between all the participant or nodes, we have communicate to each other. So all the participants need to verify, and the participant with all our soldiers and all our lieutenant to verify and reach the agreement on the single value of the output. That can be easily we have identified which message is false and which message is a true. So this is a concept in the Byzantine general problem. It is clear.
Write on the chat box if it is clear to you. Thank you.
First, we have discussed the blockchain, then after we have discussed the proof of work attack. So in the blockchain definition, the blockchain can be defined as a chain of the block that contain information. So use the secure information of item like money, property, contract, asset, music, and without a require of third-party intermediary like bank or government. So their basic structure of the blockchain. So if the block one is already always called as a Genesis block. In these block we have implemented and generated, then we have successfully completed a transaction that can be have generated the hash, and these hash we connect to the block 2. And block 2 we have also we have successfully deploy, then we have generated the hash, and these hash generated to the block 3. So inside a blockchain, so the blockchain technology support the methods for the distributed immutable ledgers and the record of transactions, decentralized peer-to-peer network, and collectively trust model among the unknown peers. Because basically we have behind the motivation of the blockchain. So we have popular popular nowadays by politician taking about this on these talking these types of technology, and news also we have discussing these types of technology. There are lots of research also we have discussing in this motivation of the blockchain technology. So there are a couple of reasons in blockchain are very popular. So one is that trust, and next is a secondly is a decentralization network. So in a trust, that means there are allow the trust various application, and they do not each other. There are various nodes in the network, so they not trust to each other. So but we have sent information from one node to the another node. So this is basic motivation. We have a trust, and second, they are allowed to run on the application or different application that can be run. So that means this is called as a decentralization network. So if the decentralization network, there we have then we have deploy, and the property of the two-way defined is the efficient and cost save effective. So these two are very important. They enable new application, and they also cut out the middleware and allow the decentralization, thus making application more efficient and possible cost effective. So their basic motivation of the blockchain technology, trust and decentralization of the network. So in this figure, we have shown the distributed network. There are different peers we have connected to each other. So if these nodes, we have performed any types of action, we have sent to the nodes, to all our nodes. And then all our nodes we have received the information. Then can we, after we have verified the transaction, and can also we have sent a message that send the acknowledgement message that can be, we have received leader node, we have received the numbers of vote that can be decide this transaction is valid or this transaction is rejected. So they are basic block of the blockchain technology, blockchain architecture. So in the particular block, we have stored basically three types of data, hash, and hash of the previous block. So if the first block, so previous hash is a 0 because it's a Genesis block. Then after we have these hash we have generated and can be stored in the next block, and this can be chain we have further from the move to the one node to the thousands of node. So if we have here the concept of the hash is a function of the hash. The participant hash is discussed or not? I'm audible?
Yeah, they have discussed initially, those people, that what exactly is there. So in brief, it has been discussed.
Okay.
So as we requested that we will be talking about
So hash
those proof of work and
after hash,
alternative.
after
That
hash
was
we
the
have,
idea.
after hash we have discussed the proof of work.
Pardon?
After hash we have discussed the proof of work algorithm, madam.
Proof of work they have discussed. Yes, proof of work previous speakers have discussed. You can repeat if you would like to. You think that for connectivity. The idea was that today we shall be giving them a flavor of other consensus mechanisms. Okay.
After second lecture we have discussed another types of consensus algorithm, because first lecture we have basic consensus.
Okay.
And use cases
Okay.
model.
Go ahead, please.
So in the hash, a hash can be understand the fingerprint which is unique to each block. So just like we have variable types of input we have received, but fixed output value we have received. So we have identified the block and all of its content, then always unique, just like a fingerprint. So here we have act as a unique fingerprint of the block. So therefore the hash very useful when you want to detect the changes and to intersection. So if the fingerprint of the block change, so if it does not remain the same block. So here we have discussed just like in these slides. So therefore the hash is a very useful when you want to detect the chance changes to intersection. So if the fingerprint of the block change, it does not remain the same block. So here input is a fox. So we have cryptographic hash function. We have received the digest message. It will depend on the F256 and 156 and 5.12 message. So we have the next input is that the red fox jump over the blue dog. So we have received the same another digest function, the same bit of representation, but we have changed the some single digit of V to U. So we have received the different types of hash message. These message we have linked to the blockchain. So we have particular block, we have changes of particular dots of and a single word we have can change that can be chain can be break in the blockchain. So in this figure we have show that here change the U and receive the different hash, and here we have changed the EV and they receive the different hash, and then last step we have received change the OE, then they receive the different hash. So that means a unique function and unique message we have received in the hashing concept. So here we have discussed the basic example of the chain of 3 blocks. So in the first block has a no procedure. So hence it does not contain the hash of the previous block. That means this is a genesis block. First block is always called as a genesis block. So block 2 contain the hash of the block 1, and while block 3 contain the hash of block 2. So here the first block is generated successfully. Then we have generated the hash of 2Z and B1, and these hash that can be used of the block 2. So here previous hash we have stored 2Z B1, and block 2 we have successfully executed. Then we have generated the next hash 7B2Z, and these hash we have stored in the next block. So this concept we have these types of hash we have connect to the one block to the another block, another block to the another block. So this is basic concept of the chain of the blockchain. So here what happened when attacker try to attack, we have in the blockchain, in the chain of the particular network. So assume an attacker is able to change the data present in the block 2, because block 1 is always a genesis block. So correspondingly the hash of the block also change. So but block 3 is still contain the old hash value of the block 2. So here we have 2ZB1 we have stored here the block 2, and then we have execute successfully. Then we have generated a new hash 7B2Z and can be stored in the block 3. But attacker try to block 2 manipulate the data. If we have manipulate the data, that can be change the hash. So, but here we have changed the hash. We have generated a new hash because we have changed some data of the block. So we have generated the block. Then we have generated a new hash AA23. But in the block 3, we have already stored in the previous hash. Is a 7B2Z. That means chain is a break. So this make block 3 and all the succeeding block invalid, as they do not have a correct hash at the previous block. So we have easily detect which particular block we have can be attacked in the network using on the previous hash. So this is what happened. We have attacked the try to the attacker in the network. So the concept of the proof of work. So a proof of work is a computational problem or a complicated puzzles that take certain time and the effort in the term of computational power to solve the computational puzzles. So in this figure, in the Bitcoin network, network can be generate the computational puzzles problem in the network. So we have miner, we have can solve the nodes in the particular block. So proof of work use the hash and nonce value. So as discussed earlier, and they complete the mining problem to solve the complex mathematical problem based on the cryptographic hash. So mining compromise the hashing a block and introducing a nonce to the hashing function and running the hash all over again. So a nonce is a number that can be used and just one in the cryptography communication. So adding a nonce as a transaction identifier make it additional unique and thus reducing the chance of duplicity of the transaction. So the nonce is a key to create a block in a blockchain database. So here we have network server generate some computational puzzles problem and send puzzles problem to the network. In the network, there are multiple nodes who can participate in the network. So we have some network, some node is they can participate in the mining, and some node cannot participate in the mining. So here X1, X2, X3, there are 3 nodes in the participate in the mining, and we have we have solved the computational problem. We have checked to the and sent to the solution to the network server. And network server we receive the X1, X2, 3, X3 solution and check the validity and we have checked compare the hash. So here we have network server check X2 is a find the correct output value. So we have X2, we have received the some incentive of the basis of the Bitcoin that can be sent to the award to the X2, and that can be X2 is act as a leader. That can be X2 send the whole solution to the all the network, and all the network we have all our node we have received the output input through the X2, and then can we have verify this receiving input is valid or not. That can be is we have while check the output solution is valid. That can be back sent to the message to the leader node. The leader node here is a X2. Then we have X2. We have received threshold of 51% of voting. All our rest of network that can be this node is a valid. That can be added in the local blockchain. That can be sent to the broadcast to the network, and it can be all our node we have received through the message to the leader that can be added in the block in the own blockchain. So we based on the local and global synchronization can be update the whole blockchain. So why to make the problem difficult to complicated, because the problem too easy to prone to the vulnerability, it will encourage the attacker to pose as the miner and fake block of their own. So proof of work discourage the attackers. So also we have protect the blockchain network from external attacks such as denial of service attack, and denial of service we have just like the center based on the centralized server attacks. And the proof of work impose some limits on action in the network, and they need a lot of effort to be executed. Therefore the attack is possible but kind of useless since the cost there are too high. So frequency of the block frequency, just like the Bitcoin transaction are being registered into the blockchain once in the 10 minutes. So miner will first check the transaction after reviewing the transaction, and the software will give a complex problem for the miners to solve the solution. If the miner can solve this problem, then the computer will give Bitcoin as a reward to the miner. That it can be solve the computational puzzles problem. So the block frequency. So we have discussed the proof of work from the hacker's perspective. So the time required, already discussed, the time required to verify the result of the computational problem is very less compared to the effort to take to solve the computational problem itself. So in case of Bitcoin, it take almost 10 minutes to calculate the required proof of work to add a new block to the chain. So considering our example, if a hacker would like to change the data in block 2, he would need to perform proof of work, which would take 10 minutes, and only then make change in the block 3 and all the succeeding block. So in the 10 minutes we have executing and verifying the block, but we have attacker, we have attack the and solve the solution in the 10 minutes, that we have generated the new block. If attacker, we have attack in the particular chain, but another different nodes cannot be changed the data. So just like thousands of nodes in the network, so we have 100, 200 years that can be solved in the the whole blockchain. So this is very difficult to that can be solved the and we have attacked the blockchain. So that means we have a immutability of the blockchain. So based on the hash function, we have just like use of the 256 parameter and 5.2 parameter. So this is point of hacker's perspective. So we have solved the computational puzzles problem and solution within the 10 minutes. So it is successfully tampered the blockchain. So we will need to tamper with all the block on the chain and read to the proof of work of the each block. So the take control greater than 50% of the peer-to-peer network. So after doing all these, you tampered block become accepted by everyone. So else this is not too impossible task. So hence the blockchain they are so secure. So how to this concept we have deployed in the proof of work. So that cannot be easily identified in the blockchain. So in the consensus, there are lots of consensus algorithm in the network. Proof of work, proof of stake, delegated proof of stake, Byzantine fault tolerance, practical Byzantine fault tolerance, IOTA, Tangle, lots of consensus algorithm. But proof of work is a more secure, is a more decentralized application of the blockchain technology. It can be tampered is very difficult. That cannot be impossible in the current time in the proof of work. So what does blockchain offer? Immutability through the hash function, privacy and security through the public key and the private key, and trustworthiness of the distributed operation and consensus mechanism. No need for central authority or middleware, as the system is decentralized and verifiable and traceable through the Genesis block. We had how the blockchain works. This is already discussed in the previous speakers. So here we have discussed the generation of the blockchain technology. So,
yes, Dr. Amreen?
yeah, yes, ma'am.
You are saying something. I'm sorry, I couldn't hear you.
Hello, I'm audible.
Yeah, you are audible. Voice is continuously low, Dr. Amreen. If you can please adjust your mic, or can be close to, can keep your mouth close to mic. So you were saying something, asking something.
Any participant is asking? Any question in the proof of work related?
That is what you are asking. Participants, you may please raise your hands if you have any questions. Okay, no questions. Okay. So we can.
So we have discussed the generation of the blockchain technology. So The first Bitcoin was mined in 2009. So here outline we have brief history of the journey of the blockchain from Genesis block to the blockchain generations. So first generation we have 2008 to 13. So the origin of the Bitcoin. So 2008, anonymous member Satoshi Nakamoto released the Bitcoin and white paper, a concept on the peer-to-peer payment system. That's it's a Bitcoin organization registered in the 2008 August. So, but first we have launched the Bitcoin in a 2009 in the January. So Bitcoin is a Genesis block mined in the January 2009. So, but this is a limitation of the Bitcoin transaction that can be only transfer from money transaction. That cannot be asset of transaction, can be transferred from the one person to the another person. So Bitcoin registered open source code, and Bitcoin recognized as a digital currency. And first Bitcoin, I think we have purchased in 2012 is a dollar of 25. So in the Bitcoin market place surprises of 1 million in the 2010. And we have generated the some name coins and Litecoin of the Bitcoin can be reached the party of the US dollar from one Bitcoin is equal to one USD in around 2011. We have then after we have 2012, we have generated the new cryptocurrency Ripple. So, but Ripple is a permission blockchain, is a launch in the payment protocol, focusing on focusing and integration with the banking system, and the Bitcoin Foundation launched in the September of 2012. Then we have moved to the second generation, 2013 to 15. So the transition which with the smart contract is based on the Ethereum. So Vitalik Buterin released the Ethereum white paper in the 2013. So sorry, establishment of the consortium over the 40 financial institutions and committed to implementing of the blockchain technology. Ethereum blockchain is founded by the crowd sales, and we using of the PayPal announcing of the Bitcoin integration, and Microsoft accepting the Bitcoin. So in the 2013 to 15, Genesis block is Ethereum is created. And also we have launched here the IBM is a Linux Foundation and Hyperledger to boost the blockchain development. But Hyperledger we have can only use and we can generate the private blockchain, not a public and consortium blockchain. So then after we have introducing the programmable contract that is called as a smart contract. So which can be checked by all the participant focused on asset or share can be between the two parties and multiple parties. And user can exchange the numerous types of assets, including properties, votes, goods, and we have music and using of some types of token. Then after we have moved to the third generation, 2015 to 18. So some bugs in the Ethereum. So we have deployed the code exploitly and causing of threats of the money. So also we have blockchain 3.0 in the distributed applications. So involved in the blockchain protocol, so industry scale of decentralization applications. So we have compiling the both involve the parties to follow the contract strictly, and we have significantly enhanced the blockchain capability, leading to its worldwide popularity. So this is a third generation of the blockchain. So we have generated the distributed applications of the apps. And the last in the current generation is a fourth generation. We have 2018 to future. So in the current Bitcoin marketplace between the 10 to 20 billions. So we have blockchain platform of the entertainment industries. We have fungible tokens and can be shared the music assets, and a business oriented hybrid blockchain projects and integrated with some IoTs, AI and big data. And also many governments and organizations are investing heavily on innovation on the applications of the blockchain in the fourth generation, just like CBC also we have included the some mark sheet 10, 12 is a blockchain based, and government of Telangana and Karnataka, we have deployed the land registry management system in the blockchain technology. There are lots of government and we have kind of investing of the of heavily in the current fourth generation of the blockchain. So this is a generation in the blockchain technology. They are core component of the blockchain: asymmetric cryptography, transaction and distributed secure and consensus and distributed ledger. So first we have create a secure digital wallet, private key, generate a digital signatures, and public key we have represent as autonomy of the user's addresses. And then we have to have a transition is a group of transition from the one block and represent a current state of blockchain, and the conversation of the value is must based on the transactions. And then after we have finally finally full the blockchain that can be, we have a block that can be apply the consensus algorithm. So a common agreement protocol and validate the block in the blockchain. So update the ledger and the block miner we have are the some incentive to the using of the proof of algorithm. But if we have used in the proof of stake, so we have some transaction fee can be received. And then we have, after we have generate the add the block in the blockchain. So basic component of the core blockchain, we have all these use of cryptography of blockchain, some characteristics of the blockchain. So here there are characteristics of the blockchain. Recording the rights of data through the blockchain will help in annual cost of saving and provide a tamper-proof ledger with other benefits such as immutability, decentralization, consensus algorithms and protocols, and distributed data control, reliability, accountability, transparency, trust, and reduced transaction costs. So we have discussed here the immutability. So blockchain technology ensure that once and data is created, it cannot be modified under any condition. All the data is distributed in a secure public ledger. So in the decentralized, a distributed ledger is a decentralized digital ledger for storing transaction or any information consistently and securely. And consensus driven, consensus is a dynamic way of reaching to an agreement on a single data value among the distributed nodes. And distributed data control, any changes of the data stored on the ledger are reflected simultaneously to all the participant node of the ledger. Reliability means any relevant changes in record is possible only if there is no consensus process, which is not true. And transparency, blockchain help in maintaining irreversible record of transaction event in sequential order, which bring more transparency in business transaction. And every in just like we have example of the any land registry deployment. So just like every transaction and every registry officer has an entire blockchain of transaction and hold a history of the transaction that can be accessed anytime from anywhere. That means we have transparency just like we have in the land registry, and also we have used in the healthcare. A trust means a blockchain based on data application shall ensure that people will start using it more social inclusions and reduce the transaction cost. Blockchain technology gives an opportunity to market participant to directly access decentralized assets and stored information. So this is the basic characteristics of the blockchain. So here we discuss the types of blockchain. You already have, I think, discussed or not.
Hello, it is in the afternoon. Dr. Amrind, if
Yes,
you
ma'am.
see the schedule that we have shared with you, in the afternoon, you only have to introduce these things like public and private, permissionless and permission, right? And right now we were thinking that you will be telling about other consensus mechanisms, alternative to proof of work. So take the flow as you think, right? But that is what was
First, we have discussed the
schedule.
types of blockchain. Then after we have discussed the consensus algorithm, just like here. Then after we have discussed some platform of the blockchain. Then after we have consensus algorithm, we have discussed it. Just like proof of work, proof of stake, delegated, proof of elastance, mutability, time.
Your voice is very low, Dr. Amrind.
First, we have discussed the types
No,
of.
we have that. I'm here only listening to you. Because you were asking that, has it been discussed before? So I told you that permissionless was supposed to be covered by you in the afternoon. Right now, we were thinking that you will be giving details of how proof of stake happens, how delegated proof of stake happens, how proof of elapsed time. And this is what was proposed here. So you can accordingly manage your flow of contents.
So first we have discussed the public-private, then after we have consensus.
Sure.
There are two types of blockchain architectures, namely public blockchain and private blockchain. So public blockchain, that means a permissionless blockchain. So it's synchronized with the public blockchain. So one does not need any permission to read and access the transaction. So we have initiated a transaction or participant in the consensus process, just like proof of work. So to create a block, so participant or node remain anonymous. So this is a basic concept of the public blockchain. So anonymous means through the high cryptographic protocols, and consider a separate sheet which can be shared by every computer in the world and is connected to the internet. And whenever a transaction is happen in the particular node, so it is recorded onto a row of the separate sheet. So, and also we have key characteristics of the public blockchain. So organization is always a public and users anonymity, but web tracking and cookies are risk to the privacy, and access that means open all and transparent to the all. And network type in the public blockchain is a decentralized, 0 point of failure. So that means one node is a fail, then we connect to the another nodes, and these nodes will connect to the other node, because it's a decentralized network and all our nodes we have connected to each other. And yes, Kishore, you have any problem? Kishore Babu.
Dr. Kishore Babu, you said there is, okay, fine. Please go ahead. Dr. Amrendra has, perhaps he's disconnected. Participants, wait for a while, he will connect soon. He's disconnected now.
I'm already connected.
Oh, you're connected. So
Yes, yes.
you have like your slide is not visible. Have you unshared?
No, I have already shared. And is visible or?
Now it is visible. Yeah.
Okay, thank you. So consensus we have used in the public blockchain is just like proof of work, and we have provided the some incentive minus to grow the network, and the security based on the consensus protocol and hash function, and higher the security and lower the performance. In the any types of we have security that can be increases, then the performance we have decreased. We have basic concept we have just like in the multiple room in the particular home. So we have all our rooms, we have a lock to the one by single lock. So we have time is more required, but we have single lock can be lock in the final room, that all our rooms we have open. So that can be easily first we have one lock is attempt in the particular first block. So we have easily first we have closed the particular rooms. So we have, but otherwise we have particular room, we have collect a single log. So we have take the time. So we have security based consensus protocol and hash function, higher the security and lower the performance is the basic concept of the cryptography. And we have trust free system, because trust is enforced by a cryptographic proof of work based on the participant. And it is a transaction speed is a very slow, because take about 10 minutes of creating a block in the proof of work. And energy consumption is very low, and scalability is a limited, because as the network grow, the node requirement of the bandwidth and storage and computational power exponentially increases. So this is a some comparison between the public and private blockchain. So centralized public blockchain is only centralized, and private blockchain also may be centralized, because they are governed by the particular organizations. And permission is to read and public. In private blockchain, it could be public or private, because it depends on the organization. And immutability almost impossible to the tempered, but in the public in the private blockchain possible to be tempered. In the organization only one person can be hold to the value. So consensus definition determination all minor. On the private only one organization, efficiency very low, and private they are superior, permissionless and permission based. So we have already discussed some key characteristics of the public blockchain. So next we have discussed some characteristics of the private blockchain. Sorry. So in the private blockchain are a great place to start or in a business to business model in the private blockchain. So the degree of decentralization, just like some centralized portion or a centralization, because only business to business, and there are two parties and one organization that can be handle the whole network. And the transparency are entirely up to the company or companies running in the configuration of the blockchain in the private blockchain. So they are there is a no anonymity, because all are participants to know to each other in the private blockchain, but in the public we have maintained the anonymity of the network. So because they do not to each other, that can be only based on the trust value. So it in the private blockchain does not require mining to validate the transaction or execute the smart contract. So it does not require a cryptographic economic incentive or token for those who are running the node, the miners. In the private blockchain is a closed environment and consisting of set of nodes which each which know each other, and they may not trust to each other because they are a private network. And before joining the blockchain network, the node have to go through the some authentication or pre-authorization mechanism through which can be validate themselves in the private blockchain. And the concept of the characteristics of the private blockchain organization in the private blockchain is a single entity or organization, users, known and trusted participant, and access fully restricted in the particular organization. Network type is centralized and a single point of failure, because any types of any organization only one person that can be handle the whole organization. In the any types of the organization, we have seen it in education based, institutions based, and company based. There can be more power that can be just like it's a centralized, a single point of failure. The operations pre-approved participant can read and write and initiate the transaction in the private blockchain. But in the public, no can be pre-approved. That can be enter the blockchain, that can be participate in the read and write and in the bind the blockchain. And verification, single validator node or central authority to create a block. You got more stake in a person, that can more chances that can be validate the block in the blockchain. And immutability secured by distributed consensus, that is called proof of stake. And voting of transaction, that can be use of the proof of a consensus mechanism. Security is a dependent on the blockchain architecture adopted, and trust based on the central control, and transaction speed is high in compared to the public blockchain. In in the seconds we have create a blockchain, but in the blockchain, but in the public blockchain we have at least 10 minutes that can we have take a time to have create the block in the blockchain. Energy consumption is a very low in the compared to the proof of work. And scalability, better scalability is high storage, and the computational power is not required in the blockchain, because no mining problem can be solved in the private blockchain. That can be only based on the stake, that can be solve the computational puzzles, and that can be solved the and can be earn the transaction fee of the particular transaction. So this is the characteristics of the blockchain in the public and private blockchain. So so why we need the private blockchain? So just like a private blockchain are used to individual, private enterprises, organizations, or a specific purpose, just like NGO may like keep a record of money spent in various school. So organization may prefer to use a private blockchain if they would like to control who can use the system, and who can write the system, write to the system, and who can read the system. So beside the organization need a solution with the mechanism to ensure user are added by a process, and user write and created, changed or deleted by unauthorized users. And these need arose and give the birth to need the private blockchain. And in addition to solution need faster transaction, proper audit trail, and intersection with the organization using of some information technology systems. So this is that we need the private blockchain in the particular network and particular organization. So then we have, after we have discussed some consortium blockchain in the slides, we have not discussed. So consortium blockchain means we have hybrid of the both public and private blockchain. So consortium blockchain is a hybrid nature. In a consortium blockchain, they read and write operation may be some restricted persons. Only certain node will verify the transaction. And let us say we have 20 different banks who have decided that they will use the blockchain technology. So out of these 20 banks, say 11 or 12 will have to sign a block verification and to put any new block on the blockchain. So we can be provide the high scalability of the network, and the high security, and the low cost and governance of the selected nodes, and focusing on the business sides. So just like we have some example, we have using of the Ripple Corda and Quorum, and custodian blockchain, just like example, Hyperledger, that can be in the market. So there are certain limited nodes that take part of in the consensus process. So therefore, scalability is the first advantages, and in the custodian blockchain, so security is the second advantages of the blockchain. So custodian blockchain scalability is more better in the compared to the security of the blockchain. So we can restrict the data access on in a custodian in a hybrid blockchain. So which is not that case in the public blockchain. So in the third advantage is the cheaper, as the transaction process involve very less node in the comparison to the proof of stake. So in the consensus blockchain, we can make changes after the code has been pushed. So any enterprise member of a custodian that has node is able to see the full content of the blockchain. Also, in the most enterprises network today, governance is left as an out of band process where the member must agree. Just like we have example in the land registry management system, just some part of land, some part of access is a public, and some part of the data can be only private network. So we have only checked the settling transaction, just like we have only owner of person, we have selling the information from land registry from one node to the another nodes that can be accessible to all our nodes, all our participant, all of the public network. But in the document of the registry of the deed registrations and the property document, that can be stored in the private network. So there's only some participant can be accessed, which particular land is a sale or which particular land can be in the process of the selling. So first we have discussed why we need the custodian blockchain. So custodian blockchain are used to private enterprises of organizations which with the specific purpose. Organization prefer to use a custodian blockchain as they prefer to control the overall blockchain, which custodian blockchains, they refer to control overall blockchain with the focus of the some particular some keywords, just like who can use the system and who can write into the system, and who can read from the system. So these types of we have need the custodian blockchain. And in the Hyperledger IBM, we can launch the private blockchain simulator is just called as a Hyperledger Fabric. So we have deployed some projects in the Hyperledger Fabric. We have discussed these types of concept. We have in later the slides, which types of network can be public and which types of network platform that can be hybrid, and which types of networks can be used beneficially from the researcher. So no royalty fees can be paid to the researcher. So classification of the blockchain. So permissions based. So permissionless blockchain, it permit any node having a valid pseudonymy account address to join and quit the network without any authorizations. Nodes can use the common node to receive, send, and validate the block. And example, just like Bitcoin and Ethereum. And permission blockchain, prior to participant in the network operations, permission blockchain, and require the proper authorization of the participant. So the effective network governance and identify relieving requirement in permission blockchain are make it ideal for multi-party or internal business applications. So this is a permissions based blockchain, and the participant based blockchain, that means a public blockchain and custodian blockchain and the private blockchain. So we have already discussed the all are these types of blockchain. So the participant can engage in the consensus process by reading and submitting the transaction if they are valid. So a set of transactions are broadcast by every node and few specialized node called a miner. So collect them to verify the validity. The example, Bitcoin, Ethereum, and some Ripple types of consensus. And example, and then we have discussed private blockchain. Keep the read permissions blockchain and write permission centralized or to a single organizations. Yes. Wait a minute. चारवीं क्लास में आना. So we have custodian blockchain, that's like private blockchain. Keep the read permissions public and write permission. So we have centralized to a single organization. Only entity in private blockchain rule the entire system. In custodian blockchain, a predefined set of nodes control and consensus process. These are partially private and operates the under group of leadership instead on a single leader. So example is a Hyperledger Fabric. So I have already discussed some characteristics of the public-private blockchain and why we use of the public-private and custodian blockchain. So the participant, you have any doubt in the public-private and custodian blockchain, that can ask. Any questions? I'm audible? लंच के बाद डिस्कस करते हैं. वही 5 बजे के बाद आना. 5. Yes, I am audible. Hyperledger blockchain can be a private network that can be used in the some existing consensus algorithm, just like Solo, Kafka, and practical Byzantine fault tolerance and Byzantine fault tolerance. We have inbuilt these types of consensus that can be inbuilt in the blockchain, that can be create a public private blockchain, just like we have used in the insurance management system, and we have one organization can be share the information. So this is a Hyperledger Fabric can be only accessed in the private blockchain, and they do not we have deploy on the any researcher can be have implement the own consensus algorithm. We have we have write own consensus algorithm comparison to the lightweight consensus in the compared to the proof of stake, delegated proof of stake. So, but we have in the Hyperledger Fabric can only own blockchain, only existing blockchain that consensus algorithm can be verify the transactions. So just like in the Hyperledger platform, so these solution for open source and all are small businesses and they often deliver the required speeds. And when enterprises come to the work, so with the enterprise requirement from the software, the more less and remain, but come the some with straight net rules about the performance, scalability, and audit. So blockchain is an open source model. So we have been available for that last to 5 to 6 years. That can Bitcoin become popular. So in the Linux Foundation took up the challenges for the open source enterprises distributed ledger networks. So IBM that can be launched in the around 2015 is a Hyperledger Fabric and approach we has to ensure the best practices of computer science, any distributed types of blockchain enterprise solutions. So Hyperledger bring into one place of multiple efforts in the computer science. There can be open standard solution, and we have provided the generic some centric protocols, Solo, Kafka, and practical Byzantine fault tolerance. And the Hyperledger project allow multiple alternative solutions. And for example, we have implementation of the Hyperledger can choose the consensus and needed for the project. So we also Hyperledger we have existing of computing knowledge, and we have some cryptography algorithm can be already implemented in the Hyperledger, just like uh, advanced encryption standard and SHA 256, both are which encryption standard algorithm. And in the Hyperledger projects can be also we have deployed in the so we have this type as per the hyperledger.org. So that can be deployed the some projects in the in this particular websites. So we have create an enterprises grade and open source distributed ledger framework and code bases, and that create an open source projects technically community to benefit of ecosystem. So there are some also we have some base types of model that can be already exist in the Hyperledger fabric. So that can be only change the some change of chain codes that can be deployed the own projects without writing of own consensus algorithm. So this is a basic concept of Hyperledger algorithm. And there are some key characteristics of the Hyperledger blockchain, just like enterprise of the grade, open source code, and distributed ledger, and open source technical community, and promote the participations, and some standard and protocols that can be already inbuilt in the network, and advanced encryption algorithm. One size does not fit to the all. So there are some characteristics of the Hyperledger blockchain. So after some after some slides, we have discussed the network with platform that can be deployed in the blockchain. So later we have discussed the Hyperledger fabric and tool, IPFS, Ethereum. In the next 2-3 slides, after 1 and 2 slides, we have discussed some blockchain platform and technology. So here is some literature study of the blockchain platform. So first we have discussed the Ethereum, Hyperledger Fabric, Hyperledger tool, and interplanetary file system. So there are some leading technology platform are like Ethereum, Hyperledger Fabric, Hyperledger Tooth, and interplanetary file system. So discussed in these slides. So first we have discussed the Ethereum. Ethereum is an open source, globally decentralized and computing infrastructure that execute program is called a smart contract. So a smart contract are simply program stored on a blockchain that run when predetermined condition are met. So Ethereum provide a blockchain to synchronize and store the system state along with the cryptographic called either to ether to pay the execution cost to the miner in the term of gas. In the blockchain, we have deployed the blockchain in the Ethereum. So we have verified the transaction. So we have pay for some transaction fees, and these transaction fees is called the ether in the term of the gas in the Ethereum. So if we have verified the 2 plus 2 in the Ethereum network, so we have paid the some transaction fees. Transaction fees is called as a ether gas. So we have already decided some types of just like we have verified the some transaction in the node. So we have some minimum transaction minimum fee of ether gas can be burned in the verification of transaction, and we have maximum fee of the also we have decided. So we have network, we have shown that a minimum this is only 2 ether gas, it is minimum that can be required, and maximum ether gas is a 10. So if we have verified the any transaction that we have given to the network is a 10 ether. So because we have just like in the base of the congestion network of congestion, if we have a basic ether is at 2, can deploy and verify the transaction, but in the base of the transaction of the network congestion, we have burned the 6 ether gas. So this action, your 2 ether can be burned, and that cannot be verified the transaction. So we have verified the any types of transaction in the Ethereum. So we have given the some particular transaction fee to the network. Basic is a 2, then standard maximum is a 10. So we have 10 ether we have given to the network. So we verify the transaction. So we take the some royalty fee to the Ethereum. So gas is a unit that measure the amount of computational effort that it will take to execute certain operations. So every single operation that take part in Ethereum, be it a transaction or a smart contract execution, require some amount of gas. In gas, the term of Ethereum is called a ether gas. Next, we have discussed the Hyperledger Fabric. So Hyperledger Fabric is the first major private distributed ledger technology system. It is originated from the Hyperledger ecosystem, and it has been designed with the strong privacy in mind to ensure that different government agencies and businesses organization can take advantages of a distributed ledger technology system in the different use cases. So Hyperledger, being a permissions ledger system, is used to authenticate a node by using a mechanism is called a membership service provider. So one of the critical use cases for the industry need is information sharing on the ledger. So while some selected information on the ledger may need to be shared in the particular nodes. So this has been persistent challenges faced in the IT system for the past 3 decades. So the Hyperledger solved the problem by using the channel is called a chain code and membership service provider. So Fabric is a part of the open source movement as already shared use cases in the supply chain management, healthcare management, and financial services that can be inbuilt in the Hyperledger Fabric. And the crucial capability of the Fabric is that it can maintain the multiple ledgers within its ecosystem. So it is useful of the future. So which separate Fabric from the other distributed ledger technology based system consistently for the only one ledger in each of their domain. So currently Hyperledger Fabric support Solo and Kafka consensus mechanism and a simplified Byzantine fault tolerance algorithm to be released in soon. So Hyperledger Fabric is not a decentralized network. Most of the time, either a single organization control it or a group with a shared responsibility. So this is a concept of the hyperledger fabric. Ethereum can be in the Ethereum. We can deploy the network. We have learned to the Solidity programming, and that Solidity programming that can be in the turn we deploy the smart contract. We verify the transaction from one particular participant. But in the Hyperledger, we have use of the Go languages. That is called in the term of Ethereum, we use of the smart contract. In the term of Hyperledger, we have called is a chain code. Then next we have discussed the Hyperledger Sutooth. So Hyperledger Sutooth, initially developed by Intel, is a software framework for creating a distributed ledger suitable for a variety of use cases. And Sutooth Hyperledger utilize a novel consensus algorithm that is called a proof of elapsed time, and which depend on Intel SGX, means Intel Software Guard Extension System. And the Intel Software Guard extension is a tested ecosystem environment and integrated into Intel new generation process. So SGX enable the execution of the code within a secure enclave inside the processor, whose validity can be verified using a remote attention process supported by the SGX system. So major drawback of this protocol, it is dependency on the trusted execution environment enabled hardware. Without these hardware, it cannot perform any types of transaction in the network. And a cryptography hash is created for every file, and these files are stored in the node, and whose indexing is done such that file can be accessed from the node. So in the Hyperledger Sutooth. So next we have discussed the IPFS, interplanetary file system. So it is a decentralized file storage system that enable the storage access and security files over the distributed file system. So there are certain advantage of using IPFS in comparison to the other Ethereum, Hyperledger Fabric, and Hyperledger Sutooth available platform. So it follow a peer-to-peer architecture that provide a decentralized way for the storage and retrieval of files. It is distributed versions file system that allow different kind of application to be built on top of it. So using of IPFS with the blockchain, we only need to store the hash of the IPFS file on the blockchain. And while allowing the users to exploit the file storage peer-to-peer properties of the IPFS system. Yes. अभी तो मेरा लेक्चर चल रहा है 10 मिनट में आ जाओ 10 मिनट बाद so sorry so using IPFS with blockchain, we only need to store the hash of the IPFS file on a blockchain. So while allowing the user to exploit the file storage and a peer-to-peer property of the interplanetary file system, it also provide data distributions, security protocols, or routing system to find the peer addresses of other peers and all other functionalities that a blockchain application require. So IPFS is an open source platform, it is not required to pay a royalty of the transaction confirmation in the compared to the another software. And this is can be only that can be use of and that can be any researcher can be develop own a consensus algorithm, so you can easily deploy own consensus algorithm in the interplanetary file system that can be compared to the another consensus algorithm in the hyperledger fabric, solo, kafka, practical byzantine fault tolerance, proof of work, proof of stake, and proof of delegated proof of stake. We have any types of algorithm that can be deployed in the network that can be easily verify ki, your developed algorithm is better or not, and can be reduce the some computational problem, and we have reduced the some message exchange problem and reduce the some computational puzzles problem. So this is a basic some blockchain platform of the blockchain technology that can be deployed and can be generate the own blockchain. It can be used on some use cases of the blockchain, supply chain management, insurance management system, vehicle accident insurance management system, land estimation system. And recently we have more trending topic in the blockchain use of the electric vehicle charging system. So we have electric vehicle charging system just like we have shared and we have created the some distributed app to have we have used in the electric charging system and electric charging stations that can be deployed in the distributed application. That can be some charging management system. We can be check the which system station that can be free, and that can be which types of station can be based on the heavy load. So the current the energy trading system that can be deployed in the blockchain technology used in the system. So this is a platform that can be deploy the own creating blockchain, Ethereum, Hyperledger, Fabric, and IPFS. So participant, you have any questions in the particular platform related to platform? Have any question related to any platform? Ledger DB, that means you have Ledger DB, that we are asking the Amazon Ledger database. So Amazon Ledger database, just like we have used in the recently we have Quantum Ledger database, is a purpose to build the ledger database that provide a complete or cryptographically verifiable history, all the changes made of your application database. So these type of ledger database different from the other database. Just like in the traditional database, allowed to overwrite or delete the data. in the so developer and some so administrative authorities. The use of the technique of edit and trial of the any types of data. So in the that can be recorded. So within the
Basically, can I say something here, Dr. Amrin?
yeah,
So LaserDB is basically very specific to Hyperledger Fabric, my dear participants. And IPFS is itself a file system, which is an open source technology, where what happens that you have the files, every file is split into chunks, and each chunk is distributed, right? With certain security measures, it is distributed. And not only one, but several copies of those chunks are distributed so that availability of the file can be ensured in right time, in perfect time, right? So these are like database here. What we are talking about is that Hyperledger Fabric maintains a state of the network, state of the any update, and accordingly the ledgers are updated, right? That's the difference. Okay. So you were asking, perhaps they were asking about IPFS and ledger database, LaserDB, and therefore I thought it appropriate to discuss here. Thank you so much. Over to you.
yes, ma'am. Hyperledger we have updated the based on the word ledger status that can be stored the based on the or different nodes. The IPFS that can be store the cryptographic hash that can be have generate the block of the particular transaction. And these hash we have can retrieve the particular block in the blockchain. So we have basically no mining problem can be based on this IPFS. That can be only based on the trust value basis. That can be easily identify your particular block is all our particular node is distributed or not. So no computational problem can be can be used in the IPFS, and all our nodes we have all our nodes we have distributed way of finance. Not particular node can be administrative power in the IPFS in the compared to the Hyperledger. So then we have a need for the consensus. So why we need the consensus? So consensus mechanism is a fault tolerance mechanism. So that is used in a computer and a blockchain not to achieve the necessary agreement on a single data value or a single state of the node among the distributed ledger. So first we have discussed we have why we consistency and consensus mechanism. So the consensus algorithm determine which state of the blockchain is chosen to be valid and true. So it is only when consensus is achieved that the new transaction is recorded into the block, and it is like the already existing chain of the block using hash pointer to the previous block. So in short, it can be said that consensus is mainly achieving the trust of the distributed node. So the node is a node in the network require a consensus algorithm to achieve an agreement on the single value. So if at least 51% of the node reach a consensus that the solution found by node is valid, and then the solution is treated as a valid solutions. So to add a new block in the blockchain, so there are various consensus algorithms like proof of work, proof of stake, delegated proof of stake, and Byzantine fault tolerance, and other types of consensus algorithm we have discussed. So there is a type of consensus algorithm mechanism. So there are some leading consensus are likely proof of work, proof of stake, delegated proof of stake, proof of elapsed time, proof of retrievability, Tangle, practical Byzantine fault tolerance are discussed in this structure. So after we have next class, we have discussed these types of consensus algorithm. Hello. Hello. I'm audible.
Yes, yes, Dr. Amrin, you are audible.
Yes, ma'am. I have some important work within 10 minutes. So we have next class. We have discussed these types of all our consensus mechanism in the discussing the structure.
Okay, so
12:30 we have discussed the all our consensus algorithm, and also we have discussed the some use cases of the blockchain technology. Just like we have showed that
So what time will you come next, Dr. Amrit?
12:30 and next lecture we start 12:30.
Okay.
So here after we have consensus algorithm, we have discussed some use cases of the blockchain technology, just like healthcare management system, banking
That we
system.
will cover in some other session, sir.
Okay. Okay.
So
Okay.
that another speaker is assigned for that.
Okay.
Okay.
Okay. Okay. So we have discussed the consensus mechanism algorithm in next lecture.
Yeah.